Okay, so chapter 1 is on inductive and deductive reasoning, and the first video here now is just going to cover sections 1.1 to 1.3 in the text, which are on inductive reasoning, conjectures, and counterexamples. And inductive reasoning is a form of reasoning in which a conclusion is reached based on a pattern present in numerous observations. So the pattern observed makes the conclusion likely but does not guarantee it to be true. So basically you just look, you come up with an example, come up with another example, and see that there's a pattern that's developing, and so you make a little rule as to what you think might be true. And a conjecture is, as I said, not necessarily true. It can be proven false though if you have a counterexample, and we'll learn what that is in a little bit. A conjecture is a testable expression that is based on available evidence but is not yet proved. So in everyday life we often make conclusions based on observed patterns. For example, analyze the picture below and develop an explanation for the possible events that may have occurred. So we have here what looks like, if you were to look at that, there's a lot of debris all over the place, and things are covered, the car is covered and with debris. If I were to look at that, I'd probably put all that together and think that there was maybe a tornado or a hurricane or something that blew all that stuff, heavy things around, and kind of covered up the car. And obviously the stuff is up on top of the roof, and that would, you would assume that there'd be some high type of winds or force that would put that up there. So that would be some possible explanations we'd have for what occurred to create that picture there. So let's look at some examples now of how we can develop patterns and come up with conjectures. So the first one says, consider the following pattern of triangles. So the first figure has one triangle in it, then the second figure has two rows of triangles, two rows which create four small triangles, and then the third figure has an extra row added of triangles, and creating 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles in that big triangle. So the next figure, if we were to guess at what it would be, would more than likely, based on the pattern that we see so far, have 4 rows of triangles making the big triangle. So this would be the first one, and then the second one would be made like that, and then the third one would be just basically connecting those endpoints, and then the last one, my row is going to be kind of squishy here, would be something like this. Can't really see that last one. So it says, construct a table of results and make a conjecture relating the number of small triangles and the figure number. So if we have figure number and the number of triangles in the pattern. So figure 1 had 1 small triangle, figure 2 had 4 small triangles, figure 3 had 1, 2, 3, 4, 5, 6, 7, 8, 9, and figure 4 had 1, 2, 3, 4, 5, 6, 7, 8, 9, and then an extra 10, 11, 12, 13, 14, 15, 16, so 16. So if we look at the numbers there, obviously the figure number is going up by 1. The number of triangles went from 1 then to 4, so that's 3 more, and then to 9, that's 5 more, and then to 16, that's 7 more. So it seems like it's going up by odd numbers, because that would be plus 3 to give you 4, plus 5 to give you 9, plus 7 to give you 16. So it would seem that the next one might be plus 3, 5, 7, 9. So we would guess that probably the fifth figure pattern would have 16 plus 9 or 25 triangles. So it says, use your conjecture to determine the number of small triangles in figure 10. So it seems like, as we said, that it's going up by an odd number each time. So if we continue our pattern here, 6 would go with 25 plus 11, because next odd number would be 11, which is 36, and then 7, 8, 9, 10. So then the seventh one would be the next, if you add on the next odd number, would be add on 13 onto that. So that would give you 49. And then the next odd number would be 15. So if I add on 15 to that, I would get 64. And then if I add the next odd number would be 17. So that's 64, 74, 81. And then if I add the next odd number onto that, that should give me 100. Alright, so that's what we would guess that figure pattern, the figure 10 would have 10 small triangles in it. So example 2 shows a triangular array known as Pascal's triangle. And if you look at the pattern of numbers here, it's obvious that in each row it starts with a 1 and ends with a 1, but then there's some numbers in between. And if you kind of see if you can see the connection between the numbers in each row compared to the previous, I'll just kind of give you a hint here. This and this add up to give you 2. So it starts with a 1, the next number is the sum of the previous 2 here above it, which is 1 and 2 gives you 3, and 2 and 1 gives you 3, and then of course it ends with a 1. So the next row starts with a 1, and if you look at 1 and 3 give you 4, 3 and 3 give you that, 3 and 1 give you that, and then of course it ends with a 1. So if we continue on with that pattern, we see that that is basically the pattern. And so the last one there, we're asked to complete the next 2 rows, so we'll start with a 1. The next number should be the combination of 1 and 6, which is 7, and then 6 and 15, which is 21 if you add those. 15 and 20 if you add those is 35. 20 and 15 is again 35. 15 and 6 is 21. 6 and 1 is 7. And then you end with 1. And then the next row would start with a 1. And then it should be 1 and 7, which is 8. 7 and 21, which is 28. 21 and 35, which is 56. 35 and 35, which is 70. That doesn't look like a 5 there. 35 and 21, which is 56 again. And 21 and 7, which is 28 again. 7 and 1, which is 8 again. And then of course it ends with a 1. So the next question or example says, consider the pattern of multiplication shown. And it has 11 times 11 is 121, which you should notice is this row of the Pascal's triangle. Third row of Pascal's triangle, and then 3 11s give you 1 3 3 1. 3 11s multiply by each other, which is the fourth row of Pascal's triangle, and 11 times 11 times 11 times 11 gives you 1 4 6 4 1, which is the next row of Pascal's triangle. So the pattern that we're seeing is that the powers of 11 seem to match the rows of Pascal's triangle. That seems to be what's happening here. So if we check to see if this is true, with the next row we would have what we call a counterexample, because 11 times 11 times 11 times 11 times one more 11, because there's 4 11s multiplied by each other up there. If we multiply that, we get 161,051, which is not the next row in Pascal's triangle. So this is not the third, fourth, fifth, sixth, not the sixth row in Pascal triangle. So it appears that this rule, this conjecture that we had is actually false. And we've proven it using what we call a counterexample, which is an example which proves that a conjecture is wrong. It's an example that kind of shows that our conjecture is a false conjecture. It doesn't actually fit what we thought is supposed to happen. So the next set of examples now is just observing number patterns. So the first set of numbers we have is 1, 5, 9, 13, and 17. So these numbers are going up by, sorry about that. These numbers are going up by 4, and then by 4, and then by 4. So it seems like they're increasing by 4. So the next one should be 21. And then the next one, oh, you only need the next number, sorry. So you just need to add 4 to get 21. Okay, if we look at the next set of numbers, there doesn't seem to be a common increase. Like these two are going up by 2, and then they're going up by 4. But there does seem to be a pattern, because this is going up by 2. This is going up by 4, this is going up by 6, this is going up by 8, so I would guess that the next one would go up by 10. So if you add on 10 to 25, you would get 35. That doesn't look good, so 35. Now the next one, when I look at that right away, I see that those are perfect squares. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so the next one would be 6 squared. 36. So there's some questions there now on pages 12 and 22 and 23 of your book that you can try, and there's also a worksheet that I have that you can, if you don't have a copy of it, it is on Schoology. You can do that for extra practice in this section.